and and so the restriction of the power plant and for the power and thrust is there, and so this means although there's when we increase the angle of the angle of climbing, the rate of climbing might also increases. Mm, but as but at some point, this plane is not capable of maintaining this angle because it doesn't have enough required power force in it, and therefore it's not capable of maintaining its lift within this point. So it will gradually drop until this thing balances. So the the our connected system is quite useful when solving for these simple steady um, these simple steady states. So we are assuming that it's not accelerating nor decelerating, and it's just a transformer version. There's no rotational things on it, and so the plane is climbing at a certain rate. But still, these characters can give you lots of information and probably find some particular solution of the kinetic state can help you solve more parameters in later solvings, like the weight analysis, and the mission envelopes and more lift analysis and lots of other stuffs. So meanwhile, this program is built as developing tools as a set of functions that does calculation and plotting and probably do some would do some basic optimization and data manipulations and these kind of very simple tests. But for it to be more useful, we're actually starting to build more connections to it, and these connection include using the result as from the previous step to for the next step and looping one step for a certain kind of requirements. Now, um, since these uh, features are not very stable, I didn't release it, and probably it's gonna be on GitHub for in the next few months, and by the end of the year we will get a more sophisticated version of this program, and we will name it and we will name it the R Aviation Explorer 3 instead of the pre-release version. So there's a so so there's a plot that's analyzing the yeah, that's a plot that's analyzing the lift drag and the required lift drag and also the lift to drag ratio at certain points. So the x-axis is the speed, and the y-axis is the angle of the tag, and these and the angle from the angle of the tag and speed to we could calculate the corresponding lift and drag, so we can make a contour line. But now we're assuming that these lift and drag coefficients are not relevant to not influenced by the speed, not by the Raymer number, which uh, measures the viscosity and lots of properties of the air. So this is just a simplified version, and also as you see, we are still using the very primitive way of input. So probably we'd use the we would use the would use the output of the alpha function to create alpha function and some other properties like the linear property of the alpha or some correction, sorry, some correction formulas for the real planes so that we are not using so that we are not using the lift and drag from the profile wind profile to estimate the plane. We are actually using some correction formulas to correct it for to correct the property to a more realistic estimation. So so that's the as you see, the green line represents the lift to drag ratio, and because we are assuming that the drag and lift coefficients are not influenced by the speed, this is going to be parallel, and the largest line, the one that's on the top represents the highest lift to drag ratio, and also in these intersect the good state that's plane is using its lift and drag. But also you don't want to use them. Um, you don't want to use them at a very extreme state. So when the real concept is performing some kind of tasks, when you can determine the text numerically, there's a way of there's a way of uh, generalizing its motion. Right. No. And this is called mm, so so we do where is it? So we should have a lift to drag. Sorry, the the load diagram, the load case for the plane. So the load factor is the n, which is the the load factor indicates how many times of force, how many how many times the force that some object is experienced with relative relate sorry uh, divided by the magnitude of the divided by the gravity. So like not magnitude, it's actually a scalar, a vector quantity. So you actually have negative values. Uh, so for the negative values, yeah. So that's load default. We haven't got a real case study for this one, so it's just demonstrate the let's just go load create name the LD create load default, right? So we could print that, and also it follows the very similar format. Here's those assumptions, and there's the list of results. So these are the 2D results. We could make some three-dimensional analysis in the future, and probably that involves some parallel computing, which doesn't always, which parallel computing doesn't always make it faster, but the lines. So as you see, this is the load factor, this is the velocity, and in within this region, the plane could fly without problems. And too much, this indicates too much kinetic energy density, which is the Q is the rho 1/2 rho v squared. So when the kinetic energy density is too large, or the load is too large, some problems may occur. So, and these two lines represents the maximum lift generated as the correct uh, maximum and minimum lift that's generated at certain speed. So if the if the plane has the status that could be projected to this 3D state sorry space of state, like here, there is no problem of flying, and within this space there's no problem, and but it so but it also should have a minimum speed to maintain its minimum speed to maintain the level flight. So usually that's about there. And also you'd have a different CL here, which represent the Kmax, the lift to drag rate, the maximum value of lift to drag ratio, and that would provide slightly less CL, but lots but also less CD, and that would be more efficient than flying along this line. So if some turbulence blow the point to like this space, the plane will stall. But this won't cause any structural damage, and you could easily, if you get a good control, you could easily get back here if you get a good control. But within this space, it's I mean, if it go beyond this line or down this line, it's gonna bring some special structural damage or structural problems, and also this line for the kinetic energy density. So these new tools are not very well developed, so they are not yet included in the version, but they could be useful because uh, they help connect the the system with lots of parameters together, and make these separate calculation to an integrated system that enables a whole, maybe a lot of function in the workflow to be done with minimum amount of code. Okay, that's all.